This will have 2, because it's a 2-dimensional problem. This will have 1, because it's a 1-dimensional problem. So I'll have 3 equations of motion. The template, equations of motion is not, you are not using any equations from chapter 2 and 3 when you do equations of motion. This has confused some students in the past. The equations of motion are based upon Newton's second law. The F stands for the total force, M is the mass that the forces are acting on, and A is the acceleration of that mass. Did I write this up last time?
Yeah.
Okay. So, as we look at the masses, we look at mass A, so I'll have 3, I'll have an I sub A hat, I'll have a J sub A hat, and an I sub B hat. It'd be really nice if no one ever puts an equal sign after those. These are just labels for, so you know from where I get my equations.
What about like a colon?
Colon would be fine.
Cool.
All right, so we look at the equation, we look at mass A over there. We have 4 forces acting on it. What are all the forces in the positive I subscript A hat direction?
Are you asking left or right?
Right.
Okay, you're right.
I define my I hat to be positive that way. And so therefore, what are all the ones pointing in that direction?
Tension.
Tension, so FT. Any others?
Yeah.
Minus, what are all the forces pointing in the negative direction?
Friction.
Is that it? So that will be equal to mass times acceleration. There's one small mistake written up here.
You're missing the vector.
Yep. All of these are in the I hat direction. I don't need to write I hat here. There is nothing that needs to be erased, but there's something I left off.
Do you need to do M sub A or something?
Yes. There are 2 masses. I need to identify which mass is which. All right, J hat. What are all the ones in the positive J hat direction?
Force of gravity.
Okay. All the ones in the negative?
The normal force.
And that's equal to mass A times. What is the acceleration in that direction?
0.
The whole point of picking one of your directions of your coordinate system in the direction of motion is so that one of the equations equals 0. If this were not equal to 0, if we picked something where neither of them were equal to 0, then we've quadrupled the amount of math we have to do. All right, down here, what is this equation going to be?
Weight
So it'd be
and the tension.
minus the tension
Or, yeah.
is equal to
Mass B acceleration is
equations of motion, done. The first S, substitution. Do we have an independent formula for any of the variables that we have here? When I say independent formula, do we have a formula that is going to be true regardless of the situation over there. Because these are all problem specific. Well, there are two at this point. We have two things here for which we have an independent equation. One of which,
Acceleration?
no,
Force of gravity, like, reverse.
yeah, force of gravity is one of them. There's, what is the formula for weight?
Are we allowed to look this up?
Sure. It is the equation that stumps most automatic readers. Computer readers.
It has to be something in newtons, right?
No, those are units. I'm looking for an equation here. All right, so let's derive it. If I have an object in free fall, ball falling, what are all the forces acting on this?
Force of gravity.
Thank you.
That's what I gravity.
Sorry if I
It's
just missed a
mass
couple
times
words.
gravity.
Yeah.
All right, so that's it. That's the only force acting on it.
Mass times gravity. For weight.
Mass times force of gravity.
No, we'll get there. All right. I'm going to plug into F equals ma. I'm going to choose down to be positive. So I'm going to let my force, well, that's the weight, and that's going to equal the mass times the acceleration. Well, what acceleration, if the only force is the weight, what is the acceleration it's experiencing?
9.8. Positive 9.8.
I'm going to nitpick that.
Per second squared.
Say that again.
Positive 9.8 meters per second squared.
What assumption did you make? Yes. So, in general, what is it?
Oh, just the force of gravity?
That's the force of gravity right there. I'm trying to figure out what's the acceleration. This is the force is equal to mass times acceleration.
Weight divided by mass.
What?
All right. I was hoping it wouldn't devolve into a read my mind exercise, but sure, go
If,
for it.
hold on. If weight is the force of gravity, and then that's a force, then mass, so F equals M times A, and weight is equal to F. Ish. Is it W divided by A?
That would be the mass. But acceleration, if the acceleration is because of the force of gravity, what do we call that acceleration? It was even mentioned at the beginning of class today.
Little g.
Somebody just said
F
it?
sub G?
No way, little g.
F sub G? Or
No,
No. Is it the little g?
it's the acceleration of gravity
there's a difference?
Thank God you thought that.
between F sub G and little g.
Yes.
F sub G is a force, little g is acceleration.
Ah!
That's the formula for weight. And the reason why it stumps the automatic readers on computer and elsewhere is that it reads that as milligrams. It is not milligrams.
Can you put a little times symbol?
Well, if it's reading a textbook or articles, I mean, the free readers, at least, are too stupid to get that. All right, so wherever I have a W, I'm going to put in an mg. So my first equation, get rid of that. My first equation becomes tension minus the friction is equal to m sub A times A. The second equation becomes m sub ag, that's my substitution in for weight. This is equal to 0 here. I'm just going to bring ya over to the right side, so that equals y sub a. And this equation, my third equation, becomes mbg minus the tension is equal to mba. There's one other independent formula we have. There is an independent formula for friction, which we haven't talked about yet, I don't think. So that presumably is going to, well, you'll get some of it tomorrow because, wait, no, wrong group. You're not doing the friction lab tomorrow.
Yeah. Can you explain the first one, how we changed it?
This one, it didn't change it at all.
Okay. Oh, okay.
Just trying to show an evolution, and we're not getting, the equations still exist even though we didn't make a substitution here. We will actually though end up making a substitution for friction at some point. Just wrapping this up somewhat quickly, without friction, if I make this a frictionless situation, the only thing that changes is that's equal to 0. So what I'd end up with is tension is equal to m sub AA. This is again, if the friction is 0. And mbg minus the tension is equal to mba. If I'm solving for acceleration, I can just add the equations. I'll add the left sides, I'll add the right sides. If I add the left sides, well, I got a tension and a negative tension here. They cancel out, so I'm just left with mbg. On the right-hand side, I'm left with MAA plus MBA. I can factor acceleration out, so I get MA plus MB times A. And solving for A, well, I got multiplication going on there. I need to strip away this coefficient, so I divide by it. And so my acceleration in our frictionless world over there, bless you, is equal to mbg, the weight of B, divided by the total mass. All I have to do is give you numbers and just plug and jump. So I guess on Monday, we'll finish up the force diagrams, get to the test level problem.
Monday?
Tuesday. Some point next week. Next time I see you. So it could be, you know, if I just happen to run across you
We're not
on the
seeing each
streets
other
over the
tomorrow?
weekend, I'll stop you and I'll do the rest of it.
Tomorrow.
Did you post the lab on Blackboard yet?
I don't think so.
Okay.
If I don't have it posted by, let's say, 2 o'clock, then assume that I will bring it.
Is MPG the same, equals,
That's the weight of the,
oh, I read it wrong, never mind.
at some point in doing, we'll get to the point where I'm gonna stop writing weight down in the force diagram, just write mg. Save ourselves a step. See everyone tomorrow?